So we are going to be working through 7C, which is focusing on sums and products of ordinates. So we have done this in chapter 1, but we will be working through 7C from the Unit 3 and 4 Cambridge textbook. So just quickly, one of the things we covered in chapter 1, where when we're adding or we're doing the product, we need to make sure our domain is equal. So if our domain is equal, then it's for the whole graph. Otherwise, we need to put restrictions on it on the part that we're adding. So be mindful of that. So in this case here, we can see that if I am adding f of x equals x to x squared, because they're both 0, they're starting here, but we can see that the green graph is what is being added. So because we're adding a negative here, it's going down slightly before it goes up. So these are rules that we need to understand of addition of ordinates, but it is just common sense, and that's why I'm just going to go skip over this, and I'm going to do it with some examples. So the first thing we need to do when we've got two equations, we've got e to the power of negative x and 3 sine x. Find the rule for f plus g. So the first thing I want to do is double check, is the domain the same on what we're using? If not, we have an endpoint, and that is a point that we can plug in and to determine what is the endpoint for our new graph. So because they are both real numbers, it means it will go on forever. So straight away here, I've got f plus g, x is equal to 3 sine x, and I'm adding it to my f of x, which is e to the power of negative x. If I wanted to find the rule for fg, again, I need to go back to this table. So I know both are real numbers, so it is for the whole graph, and I'm just timesing them together. But when we're timesing it, the e to the power of negative x will be put next to the amplitude. So I'll just rewrite it as 3e to the power of negative x. If I'm evaluating for 0 for f plus g, all that means is I'm just substituting 0 into x for both of them. Now straight away, and I'm breaking this down separately, we know if we have sine to the power of 0. So if I grab out a pen and I draw a Cartesian plane, now if I think about here, this on a unit circle, this is 1 and we've got 0. Then up here, we've got 0 for x and y is 1. So a unit circle helps us to quickly know what sine 0 is. At 0 degrees, which is over here, sine refers to the y is 0. So that means 0 times 3 is a 0, and I'm left with e to the power of negative 0. Now, anything to the power of 0 is 1, because negative 0 is 0. So the answer is 1. If I look at evaluating fg for pi over 2, all I'm doing is substituting pi over 2 in. Now, I'm just, again, going to look at this sine pi over 2. So pi over 2 refers to this part here as at 90 degrees of my unit circle. We know sine there refers to y-axis, and y-axis is 1. So that is really saying 1 times 3e to the power of negative pi over 2. Timesing by 1 doesn't do anything. I could leave it in this form, or if I wanted to, I could get rid of the negative power by taking it to the bottom and make it 3 over e to the power of pi over 2. And this is me just keeping it in this form without putting it into the calculator and getting it as a decimal. Let's look at sketching. So if we're sketching the graphs of f of x is equal to e to the power of negative x, and g of x is equal to 3 sine x. The first thing that we had to do is check out the domain and make sure that we're talking about the same area. If we were, we'll be restricting it on based on what is common. The next step is we are going to graph 3 sine x separately and e to the power of negative x separately. I'm not going to go over how do you graph those. I'm just going to place them there and I'll talk to them because this is something we've already covered. So we know e to the power of x is an exponential. It's going to go through 1. The negative just means it's flipped. We know 3 sine x, it's got a 2 pi its radius. So that's why I've broken it down into 4 parts. I've kept it as 1, 2, 3, 4, 5, 6 because we're not just dealing with pi. So that's what I've done. The next step is we need to slowly put on the points that we need. So right here, they are both roughly going to be at 0. So I start out at this point. This graph here is basically at 0 at this point. So the first couple of points will stay very similar. Here, they intercept slightly north. So when this is 0, it will be at this point. So where do they cross? And that is where I'm putting my point. Now, because I've got this graph here, I'll change markers so you can see it more. This is more than 0. So this is positive, and the rule was it will be greater than both than the than both those graphs. So it's going to be up here. So that's why I put a point here. The next thing, when one of them is at the origin of 0, it has to be going through this point right here. The next step I need to think about is I'm adding, this is positive and this is negative, so that means it's going to be between those 2 points. So it's going to be somewhere in here. And then finally, because this is exponentially going higher, it's going to turn around, and regardless of what this is doing, it's going to keep on getting higher. So now I can draw my graph.